Okay, we're on number 20. It says, using the limit definition, prove the limit as x approaches 2 from the right side of the rational function 1 over 3x minus 6 is infinite, right? Now, of course, we're going to use the m delta definition now. I'm going to whiteboard to do that. And we're on problem number 20 now. And let's write that down. So what's number 20? 20 is the limit as x goes to 2 from the right side. And it's going to be 1 over 3x minus 6 is infinity, right? Let's just go through that from a pre-calc perspective or a calc 1 perspective. When you look at this, it's 2, and you're on the right side of it, all right? Now, there's only 1 0 on the problem, and that's at the bottom. The bottom becomes 0 at 2. On the right side of it, you took a test point, I don't know, like 3, you plug it in, it would be 1 over a positive number. So I definitely know it's positive. Now, again, if you plug in the 2, you'd get an infinity, you get 0, when 1 divided by 0 is an infinity. So I'm going to say that seems reasonable, and you've done these before in pre-calculus, and certainly you've done this in calculus. Now, of course, reasonable is nice, but they're asking you to prove it. All right, so let's go through the proof. And again, this is going to be the m delta definition. So what do? We're given, and this is where a lot of teachers would say let. But I'm going to say given that we have m greater than 0. All right, then what are we going to do? We're going to choose, whoops. We're going to choose a delta. I don't know what the delta is, by the way. All right, but the delta is going to be written in terms of m at some point. So what do I got to do? I got to suppose that the distance between 2 and x, let's write this down, and I'm going to write down x minus 2, is less than delta and greater than 0. Now, by the way, I'm going to say that this is fine to write this down, but I'm looking at this over here, and if you're to the right of 2, the absolute value of x minus 2 is just simply x minus 2. So I got this now, which might be easier for me to handle at this point, all right? And again, because I'm to the right. If I was to the left, it would be 2 minus x, all right? So what I'm going to do now is I'm going to do this check part. It's always a tough part for me. The absolute value. Oh, no, I'm sorry, not absolute value. And reason we know it's positive, by the way. So it's going to be 1 over 3x minus 6. I'm going to kind of factor out a 3 in that now. So it's going to be 1 over 3x minus 2. And then I'm going to look at this, and I want to kind of think about it. And what I'm thinking about, I'm actually thinking about, what I wrote down before. I wrote this down before. Now, x minus 2 and delta are both positives, so I could take their reciprocals. And what would you get? You get this over here. So I could write this down now, 1 over 3 delta. Now, if you want to do that, you multiply both sides by 1/3. Certainly legitimate. And I'm going to say I know this relationship now. This is that relationship over there. So it's, 1 over 3 delta. And I'm going to set this equal to m now, right? Can I figure out what the delta is in terms of m's? Let's write this down. And I could solve that. It looked pretty simple, right? 3m would equal 1 over 3m delta. So I'm done. I'll write this down for you, 1 over 3m. Again, I'd write down QED. I want to remind you this problem set comes from Black Pen, Red Pen's YouTube series. And what I'm going to put down now is what Black Pen, Red Pen puts down, which is square box, shades it in. And he says he's done. Thank you.